Why does Venus spin backwards? Picture this. You're standing on Venus. You look up, and the sun rises. In the west. It sets in the east. Every other clock in the solar system runs one way. Venus runs the other. Today, we're figuring out why our closest planetary neighbor decided to spin against the grain of the entire solar system. What backwards actually means. Almost everything in our solar system rotates the same direction, counterclockwise when viewed from above the sun's north pole. The sun spins that way. Earth spins that way. Jupiter, Saturn, Mars, all counterclockwise. Everything inherited the same spin, like debris caught in a whirlpool. Venus breaks the pattern. It spins clockwise, a motion scientists call retrograde rotation. And it's not subtle. If you could watch Venus from above, you'd see it turning the opposite way from Earth, Mars, and the Sun itself. It's also incredibly slow. Here's where it gets stranger. Venus doesn't just spin backwards, it spins painfully slowly. One full rotation takes 243 Earth days. Compare that to Venus's year, which is only 225 Earth days. That means a single day on Venus is longer than its entire year. Put those two facts together, and something wild happens. Because of the combination of its slow backward spin and its orbit, a single Venusian solar day, sunrise to sunrise, works out to about 117 Earth days. So what caused this? Scientists have a few leading theories, and honestly, nobody has 100% nailed it down. Theory 1. A massive collision. Early in the solar system, things were chaotic. Planets were routinely smashed by other planet-sized bodies. One idea is that Venus got hit by something enormous, hard enough to flip its rotation or knock it into a backward spin entirely. Theory 2. Tidal effects and its thick atmosphere. This one's more subtle. Venus has a brutally dense atmosphere, about 90 times the pressure of Earth's. Some researchers argue that over billions of years, friction between that thick atmosphere and the solid planet, combined with the sun's gravitational pull on Venus's atmosphere and interior, gradually slowed Venus down, stopped it, and then tipped it into reverse. Essentially, atmospheric tides fighting against solid body tides could have flipped the spin direction entirely. No collision required. Theory 3. It was tipped over, not truly reversed. A different way to look at it. Maybe Venus wasn't hit hard enough to reverse its spin. Instead, an early impact could have flipped the planet almost completely upside down, tilting it nearly 180 degrees. If that happened, Venus would still be spinning the normal way relative to its own axis. Just that axis is now flipped, so from our point of view, it looks backwards. Most planetary scientists currently lean towards some combination of a violent early collision, plus billions of years of atmospheric and solar tidal breaking. But this is still an active area of research. Why this matters? This isn't just a fun trivia fact. Venus is often called Earth's evil twin. Similar size, similar rock composition, similar early conditions. Yet it ended up as a scorching, crushed, backward-spinning hellscape, while Earth became habitable. Understanding why Venus's rotation is so different helps scientists model how planets evolve, how atmospheres can spiral out of control, and what conditions push a potentially Earth-like world toward disaster instead. That matters enormously as we search for habitable exoplanets elsewhere in the galaxy. So next time someone tells you the sun always rises in the east, remind them that's only true on this planet. On Venus, thanks to a wild combination of an ancient impact and an atmosphere thick enough to bend the rules, the sun rises in the west, and a day lasts longer than a year.